Okay, page 2. Now the first problem on page 2 is x to the third minus 5x squared minus 6x over x squared minus 2x minus 3, and that's f of x. And of course, every time we do these, we factor first. And so we're going to see if we can factor this. And a lot of students forget that this has, you look for something in common to start with, and this has an x in every term, not x squared, so we can write x, and then we can write parentheses, x squared minus 5x minus 6, and the denominator is x squared minus 2x minus 3. And if you have trouble factoring, you can get some assistance from your calculator by just typing that into the quadratic formula or graphing that, and it'll show you 2 places it factors to, but you shouldn't have to do that. You should know that this is going to be x and x. They're going to subtract, so 6 minus 1 would be 5, so I'm going to use 6 minus 6 plus 1 would make minus 5. And then the denominator, this factors to x. See, that would be minus 3, and x plus 1 would give us minus 2 in the middle. So factor, you should show that. So then you can tell me what are, if there's any holes. So now in this factored form, these cross out. So there's a hole at -1 in the x. And to find the y value, you put in -1 into what's left. So that'd be -1 minus 6 over -1 minus 3. So that's -1 times -7, or 7 divided by -4. So it's -7/4. That's where the hole is located. Then for vertical asymptotes. And that's anything that makes the denominator equal to 0 without not counting the holes, and so that'd be at x. It's a vertical line, so it's x equals 3. The graph does not touch that one. And then you should give me the behavior. And since it's a single factor, that should be opposite. In other words, on one side of that asymptote it's going up, and the other side it's going down, or vice versa. One side up and one side down. That's the behavior. Then we look for horizontal or oblique asymptotes. And in this case, the degree of the numerator is 1 more than the denominator, so it's going to be oblique. And I can go back and do long division of this into this and find it. Let me do that, because some of you struggle with that. So I'm going to write x squared minus 2x minus 3 into x to the third minus 5x squared minus 6x. Make sure you can see all that. Yep. And then x squared times what makes x to the third? That would be x. X times x squared is x to the third. X times -2x is -2x squared. X times -3 is -3x. Now I've got to draw the line and change the signs. Now I can add. Those are gone, and I end up with -3x squared minus 3x. X squared goes in there, -3. -3 times that's -3x squared. -3 times -2 is plus 6x. and negative 3 times negative 3 is plus 9. Draw the line, change the signs. These add to be 0, and I get negative 9x minus 9. I don't really need to know this because this is my slant asymptote, oblique asymptote. Y equals x minus 3. Okay. Now, since this was reduced to this one, I could have used synthetic division on this one and got the same answer. Let me show you that. So this would have been x squared minus 6x over x minus 3. So I'd want to put in 3 into 1x squared minus 6x plus 0 for the constant. 1 brought down times 3 is 3. That would be minus 3 times that's minus 9. And that comes out minus 9. So there's my minus 9 over what I'm dividing by. But here is my oblique asymptote. Y equals 1x minus 3. Same thing we had here. 1x minus 3. So I could have done synthetic division to get it, since it was down to a single factor. Alright. Oblique asymptotes, and then it asks for x-intercepts. And so that would be anything that makes the numerator 0 except where the hole is. So I'd look at this and I'd say 0 and negative 6. 0 will make x being 0 will make the y be 0. And 6 will make the y come out to be 0. And y-intercepts, I'll put in 0 and I'll get 0 times something, which is 0 over negative 3, which is 0. And now I'm ready to graph this. It had a hole at negative 1 and negative 1 3/4. Negative 1, negative 1 3/4, there's a hole. And there's a vertical asymptote at 3. And it goes opposite on either side of this. And then there's a horizontal asymptote of, an oblique asymptote of slope of 1 through minus 3. So it goes through minus 3 with a slope of 1. And x-intercept is 0, 0, y-intercept 0, 0, and another x-intercept at 6, 0. So now, that was the x and y-intercepts. So now if I graph this, it has to hit the hole, has to go through here, can't come back down, so it must be going up, and it must be getting closer to this, and so it must get closer to this oblique asymptote. And if it's here, it's probably over here, and it says it crosses here, so it probably gets closer to the oblique asymptote and closer to this x equal 3. So now if I'm to answer the last question, which is when is f of x greater than or equal to 0, this part is not, this part is. So it goes from 0 to 3, and it can be equal to 0, so I can keep the 0. I can't keep the 3 because it doesn't get to it, so I should have had a square bracket on 0 and a parenthesis on the 3. Union, this is all negative, this is all negative, but this part's positive for x from 6 and up. And it's 0 at 6 and up. So there is the graph and that. And on the graph, I want to see all the information that you've figured out for the problem. The holes, the vertical, the behavior, and all that sort of stuff. Okay, now we're down to the final two, which are pretty simple. Write a fourth degree polynomial, and this could be anything, that has a 0 of 3, so that means it must be x minus 3. Negative 5, so that means it must be x plus 5. And this is a polynomial, so it's f of x. And it could be multiplied by something, but I'm not going to. And then it has to have 1 minus 2i. Well, if it has 1 minus 2i, then its complex conjugate must be 1, which is 1 plus 2i. So now I'm going to write x minus 1 plus 2i, because I'm subtracting all of this, x minus this. So that minus goes to both of them. And I'm going to have x minus this, which is going to be minus 1 minus 2i. And that's a degree 4 polynomial that has these three zeros and the other one that would have to be. Now it says on 5 to solve this. So if I think about the graph, it bounces at negative 1. It goes straight through at plus 1. And it goes straight through at negative 3, because it's single factor, and there. And I'm using what makes these be 0. Negative 1 makes this be 0. Plus 1 makes that 0. And negative 3 makes that be 0. So it goes straight through there at negative 3. It bounces at negative 1. And it goes straight through here. And if I look carefully at this, I've got x squared. So I got x times, in this one I'd have a negative x. And this one I have a plus x. So this would be negative x to the 4th. So x to the 4th, both ends are up or down. And since it's a negative, both ends are down. It went through here. It bounced. And then it went through. So when is this greater than 0 or equal to 0? Well, it happens from negative 3 all the way up to 1. This curve is greater than 0 or equal to 0. So from negative 3, it's 0, and every place in between it's 0 or more, up to 1. And that's the sample test.